All right, so I'm going to go over every single one of these questions. So this way, over the weekend, to help you prepare for the retake for this portion, you can watch each of these questions. All right. So when we go through, I'll highlight which question we're on, and then from there, you'll know that question. You can skip around the video until you need it. So here is question number 1. So I did separate this into full repeating and partial repeating because there are slightly different things that we have to do. On your test, I'm not going to tell you, though, if it's full or partial. The way that we know that this is full repeating is because that bar goes over the entire digit we have, 1, 8. So there's no digit that's not part of the repeating pattern. All right, this says 7575, so I know that this 75 is repeating. And the same thing, 339, we know that that is repeating as well because of the whole thing being over to 339. So here I see it's partial because it's only over the 6. It's 9, 1, 2, 1, 2. So that means this 1, 2 is repeating, not the 9. Here it's over the 9 and the 0, over the 4 and 1, and over the 3 and 5. So when it's partial, it's a slightly different thing that we have to do. So let's go ahead and convert 0.18 repeating to a fraction. The first thing that we do for all of these, this doesn't change, is we see where does that repeating decimal pattern end. So here's that repeating pattern where it ends. I know it will go 1818 after this. And it ends in our hundreds. It's tenths, hundreds. So then I need to multiply this value by 100 or wherever that place value is that it ends. So it becomes 18.18 repeating. Our goal is to get rid of all of our decimals. So in order to get rid of the decimals, we first need to take out that pattern into a whole number. Because if we don't and we just get rid of our decimals as is, we're going to be left with 0. So we need to move that pattern out into the whole number, and now we're going to get rid of our decimal. And remember, when we multiplied it by 100, we have 100 of those. And now I'm going to subtract the original fraction because the whole thing's repeating. So when it's a full repeating, we just subtract because the decimals will always line up. We don't need to really think about it in any other way. And we're subtracting one of those decimals. So we had 100. After multiplying it by 100, we have 100 of them, and we're subtracting 1. So there's 2 subtraction problems we need to do. Well, when we do this, it's going to get rid of all of our decimals. And in this case, when it's the full repeating, it's always just going to be that whatever the repeating decimal is, because it's going to be subtracting 0 from it. So it's 18. But here, the total that we have is we had 100, which is the 18.18, and we subtracted one of the original, so now we have 99. All right, so some of you were just doing 18 over 100 on your test. When we do this, now we create our fraction, 18 over 99. All right, so now you'll look and see, well, which numbers divide into it. Remember, we check 2 and 3 first because they're the easiest to do. Well, I know it can't be 2 because 99 is not even. So by eliminating 2, I'm also eliminating 4. I'm also eliminating 6, 8, 10, and 12 because they are all even numbers too. And if 2 can't go into it, none of those others. So then 3. Well, I know 3 goes into 18 and 99, but just to remember how you can check is you add all your digits, and if it's divisible by 3, the whole number is divisible by 3. So then we divide by 3, so this gives me 6 over 33. And then we look again and say, well, can I keep going? Yes, they're both divisible by 3. So then I can go ahead and say 6 divided by 3 is 2, and 33 divided by 3 is 11. So 0.18 repeating is 2 elevenths. All right, so if you knew that 9 went into it right away, then go and divide by that. But I'm just showing you that no matter what, we can just do 2 and 3 over and over again until we can't do it anymore. All right, so now we see 0.7575 dot, dot, dot. Remember that dot, dot, dot is saying if there's a pattern that's going there, we just repeat that pattern. So when I see 75 and then 75, I see that that is the same as 0.75 with the bar over top. So if that 7575 dot, dot, dot confuses you, rewrite it into the way that makes more sense. And then from here, it's the exact same thing that we just did on the problem before. This repeating pattern ends at the 100, so I will multiply by 100. So I get 75.75 repeating. And that means I had 100 of them after multiplying by 100. Then I need to subtract my decimals out. So since it's full repeating, I don't need to worry about any kind of manipulation with here. I can go ahead and just subtract the original decimal because the decimals are lined up. And that's subtracting one of them. So then I'm going to subtract down, and this then gives me 99 total. And the number that we're actually focusing on is 75. So we had 99 total parts, and 75 was the number that we had. So then we will go ahead and create the fraction of 75 over 99. Well, I know that 2 doesn't go into both of those because they're both odd. So let me test 3. Well, 7 plus 5 is 12. 12 is divisible by 3. So yes, I know 75 can be divided by 3, and so can 99. So this gives me 25 over 33, and they don't share any common factors after that. So 25 over 33 is your final answer. All right, so for this one, same thing. This one's just a little bit harder now because we'll have bigger numbers, but it's the same thought process, same everything. So as long as if you know how to simplify and divide by 2s and 3s, it really isn't any harder. But now this number ends in the thousands, so we will multiply by 1,000 instead of 100, so it's 339.339 repeating. And we had 1,000 of those now. And then I'm going to go ahead and subtract out to get rid of my decimal. So since it's full repeating, I don't need to worry about anything else. And we're subtracting 1 from the total amount there. So now we have 999. And here we then have 339. And now we can, because we aligned up all of those decimals, so now we can create the fraction of 339 out of 999. I see here 339 and 9. I know 3 goes in all those, so I don't even have to check by the addition, but you can if you want. So this gives me 113 over 333. All right, so partial repeating is almost identical to the full repeating, but there is just one slight change, and we'll talk about that change. First step it's the same. We look and see, well, where does that repeating part end? So it ends, because only the 6 is repeating, it ends at the hundredth. So we still are going to multiply by 100 just like we would have before, because we need to pull out the entire repeating decimal part and only be left with that repeating decimal. If there's a non-repeating part of it, we need that to be fully into the into our whole number portion, so that this way we can make sure all of our repeating decimals align. So we multiply that by 100. So we have 100 of those. So the mistake that some of you are making in your test is you just subtracted the original decimal, but then you just got rid of the 2. You wrote it like this, so you completely changed the problem that we had. But if you just try to subtract by the original decimal, well, they don't align. The 6 repeating will have that 2 over top of it. Yes, the rest of the 6s will align for the rest, but we have that original 2 that needs to be adjusted. So what we need to do is we need to move this black decimal so that the repeating decimals align as well. So if you notice, they just need to move over one place. So what we do is we then take that original decimal, and now we say, well, where's the non-repeating part? And that's here. And we remove the whole non-repeating part out. So same thing is, well, where does that end? And it ends at the 10th. So we can multiply this by 10 to move that non-repeating part out and only have the repeating decimal left over. So you see now those 6s repeating completely line up exactly. And this is where it is a little bit different. It's not 1 that we're subtracting anymore, it's 10, because we manipulated this number by multiplying it by 10. So now it becomes 100 minus 10, which is 90, and 26.666 repeating, these will cancel out, so it just becomes 26 minus 2, which is 24. So some of you were doing this part correct, but then writing 99. Some of you were doing this part correct, but then writing 26. So you're kind of mixing up the 2 and not really doing the full thing right. So once you do this, now it's the same as before. We create the fraction. I see that they're both even, so I know that they're both divisible by 2. So I'm going to divide each by 2, so it gives me 12 over 45. 1 plus 2 is 3. 3 is divided by 3, so I know that's divisible by 3. 4 plus 5 is 9. 9 is divisible by 3, so I know what 45 is. So let's divide each by 3. So this gives me 4 over 15, and nothing else can reduce with that. So that is our final answer. All right, so for this one, I don't write the bar on it because you have to know how to identify these in different ways. So I see 9, 1, 2, 1, 2. So on your test, maybe you take a different highlighter, different colors, and highlight each of the same colors are the same. And then maybe this helps you see that the pattern. So yeah, there is a 9 there, but I never see that yellow again or the 9 again. But I see the purple or the pink, green repeating. So maybe that helps it jump out at you. So this is actually saying 0.912, and that 1, 2 is repeating. So just converting it like this puts it in a way that might make a little bit more sense for you. And now we look and say, well, where does this repeating decimal end? Well, it's the 10th, 100,000. So it ends at the thousands. So I need to multiply that by 1,000. So now I get 912.12 repeating, and I had 1,000 of them. And then I look and say, okay, If I just subtract 0.912 repeating, nothing lines up. So I can't just subtract down. I need to manipulate it one more time to make sure that my repeating decimals align. So then I look and see, okay, well, where's that non-repeating part? Well, the non-repeating part is here, just the tenths. So I multiply it by 10. So now by doing that, it aligns my repeating decimals up perfectly. But the thing that you have to remember is now we're not subtracting 1, but we're subtracting 10. So this is actually 990, and this is going to give me 903 because these all eliminate. And then I create the fraction 903 over 990. I know both of these are divisible by 3 because I see all 9s and 3s and 0s. So this is going to give me 301, and this is then going to give me 330. Well, I know that 3 plus 1 is going to give me 4, so that's not divisible by 3. They're both not even, so not divisible by 2. This is our final form that we have. All right, so for this problem, this one might be hard for some of you because you might see that it's 90, and you might think, oh, okay, we don't really have to worry about that 0. And the common mistake I've seen students make is they only repeat that 9. But this is actually saying 0.390 repeating, so it's 9090. So make sure that you are including that 0 in your work. So same thing, I look and say, okay, well, where's the repeating part n? It's at the thousandths again, so I multiply by 1,000. So I get 390.90 repeating, and I have 1,000 of them. Then I look and say, okay, well, where is this decimal non-repeating part? And that's just the tenths, so it's been the same one. Let me use a different color. It's been the same one now for a bit, but we are now multiplying it by 10. So it gives me 3.90 repeating, and I have 10 of those. I'll subtract down and subtract down in both cases. So we get 990, and we get 387. All right, then we're going to go ahead and create the fraction of 387 over 990. Both of these are divisible by 3 because 3 plus 8 is 11. Plus 7 is then going to give me 18, and 18 is divisible by 3. So if I do 387, in case you guys need help with it, divided by 3, it goes into it one time. We subtract down. So it's 0, so I bring the 8 down. 3 goes into 8 twice. 8 minus 6 is going to give me 2. Bring the 7 down. 3 goes into 27 9 times. So when we divide this by 3, it gives me 129 over 330. And then from there, we look again and say, okay, well, 1 plus 2 plus 9. Well, that's going to give me 3 plus 9 is 12. So 12 is divisible by 3, so the whole thing is. So I know then that 3 goes into 12 4 times, and 3 goes into 9 3 times. It goes into 330 110 times, and that is your final answer. All right, I starred these because those are going to be like N plus problems, meaning that these are just the hardest ones. It's the same thought process, same everything, just it's going to be larger numbers, which might make it harder for you to simplify. But from here, same step. Where does it end? Well, 10, 100, thousands, 10,000. So this repeating decimal now ends at the 10,000s. Maybe use commas when you guys are doing this too, because some people in your test, you switch from like, without writing the commas, you just dropped one of your digits. So it might just be easier for you to identify that you're doing that if you leave the commas. So by multiplying it by 1,000, we then will pull out the non-repeating with the repeating portion of it, and then just leave the repeating decimal over. But now this one, we look and see, well, where's the non-repeating part at? Well, now it's at the 100th, so now we need to multiply it by 100. When we multiply it by 100, we then pull out that non-repeating part and only leave the repeating part behind. So it becomes 35.41, and now we're subtracting 100 of these. All right, so now when we subtract down, it's not 10,000, it's 9,900, and here it'll be 3506, and they all cancel out. All right, so now we create the fraction of 3506 over 9,900. All right, once again, there's different ways we can go about doing this. I see that they're both even, so I'm just going to go ahead and divide by 2. So 3506 divided by 2, well, it goes into 3 one time. We subtract, that gives me 1. We bring down to 5. It goes into 15 7 times, so it gives me 14. 1, we bring down to 0. It goes into 10 5 times, and then 6 3 times. So it's 1 7 5 3, And 9,900 divided by 2 is 4,950. And then that doesn't reduce anymore, and that will be our final answer. All right, and then the last one, this is exactly like the one before. It ends in the tens, hundreds, thousands, 10,000. So we multiply it by 10,000. So we get 5035.35 repeating, and we had 10,000 of them. Then we're going to go ahead and take that same number. Now we need to remove the non-repeating part out. So this way we align up our repeating decimals so that they can cancel. Well, it ends at the 100, so we multiply by 100. So we had 100 of them, and it gives me 50.35 repeating. And now we're going to go ahead and subtract down. So this then gives me 9,900, and this one gives me 4,985. We can then say 5 minus 0 is 5. We can't do 3 minus 5, so we'll borrow from 50 and make it 49, and that gives me 13. That gives me 13 minus 5 is 8, and then we have the 49. All right, then we create our fraction of 4985 over 9900. So I look here, I see it ends in a 5 and it ends in a 0, so I'm going to divide by 5 this time. So 4985 divided by 5, well, it doesn't go into 4, but goes into 45 9 times. So, I'm sorry, 49 5 times. So we subtract, then we bring down the 8. It goes into it again 9 times. So 48 minus 45 is 3. Bring down to 5, so it goes into it 7 times. So this is now 997 in our denominator. And then 4985 divided by 5. Oh, wait. That's in our numerator. Sorry, I already did that one. So we have 9900. So it goes into 9 once. Subtract 4, bring down to 9, so 49. So it goes into it 9 times. Minus, that gives me 4. Bring down to 0. It goes into 48 times. And then we had that one more 0. That 5 goes into 0 times. So then it makes it 1980. And this doesn't reduce anymore. So that would be your final answer.